today we're going to do a little something different. As you can tell, we're in a different spot. Got a whiteboard, got a whole bunch of stuff on the table here. We're going to go over a little bit of map reading and land navigation. Now, I'm pretty sure, hopefully, everybody here has seen a map before, okay? This one, you know, they open up, they have a bunch of terrain features on them, have a legend, a giant piece of paper. But do you know how to read a map? And if you can read it, do you know how to navigate using it? Okay, so what is a map? A map is a portion of the Earth's surface as seen from above, drawn to scale. Pretty simple, right? So basically, they just took a giant picture of a portion of the Earth's surface, they drew all the stuff out on it, and then they made it to scale, all right? On a map, and I'm gonna insert some still pictures of this. On a map, you're gonna have all kinds of stuff that is in the legend, okay? One thing you're gonna have is you're gonna have adjoining map sheets, okay? Adjoining map sheets are, you have this portion here, but what's this map and that map and that map and that map? Because sometimes you may need more than one map, depending on where you're going, depending on where you've been, things like that. So like, this is Moab South, and then here it has like Moab North, and it has Moab Poison Spider Mesa, and Slick Rock, and Green River. So it basically just shows you where the adjoining maps are, right? And the other thing you have on here is you have different colors and different features of like, what is a road, what is a primary highway, what is a secondary highway, what is a four-wheel drive trail, what is water, where are the gas stations, where are the places to go camping, things like that. Everything you're going to need to know, so you can, maybe you're going to go camping and you want to go on a four-wheel drive trail to get there, you got to know where the camping spot is, right? They have mountain biking trails. Even this one has a temperature chart for the weather through the months. Another thing that they're going to have is they're going to have when the map was made and also when it was surveyed. So the map may have been made in 1960, but they surveyed it in 1990 and there was no differences in the map, so they continue to use the same map. Another thing they're going to have is they're going to have the scale. Like this is 1/70,000. What that means is 1 inch on this map means 70,000 inches in real life. 1 foot on this map means 70,000 feet in real life. So 1 of something means 70,000 of something in real life, okay? They're gonna have another scale in here, just kind of shows you miles, kilometers. They're also gonna have, on this map here, they're gonna have what is known as declination, okay? There are 3 different kinds of norths. Now, if you don't know anything about map reading, you might be thinking, what the fuck are you talking about? So there is a grid north, which is the lines on the map going up and down, okay? That is your north-south line, okay? There is magnetic north, which, if you know, there's a magnetic pole in the North Pole, and that draws all the compasses, and that's what makes the compass go north. So there's a grid north, a magnetic north, and then there's a true north. True north is the North Star, okay? The star pointing north. And I have right here. So I have this little thing from, where is Navigation Boss, the 16-piece land navigation kit. It's actually a really good little kit if you buy it, and it has a bunch of little stuff in there. Like this one, true north is the axis of Earth's rotation, magnetic north is the magnetic field, and grid north is the lines on here, okay? Now, there's always going to be a difference in all 3 of those, okay? This is in Moab, so it's in Utah, and Utah's here, and let's say the North Pole is here, right? So there's going to be a little bit of difference. Well, let's say the true north is over here, so now you have here, here, and here. So you're going to have a little bit of differences in all that. Another map, like a military map, 1/24,000, okay? Same thing, 1 inch equals 24,000 inch on here. And I'll take better pictures and zoom in on this. It'll have like a little graph that shows true north with a star, and then grid north, and then magnetic north. And it'll show like this one is 17 degrees to the east between true north and magnetic north. And grid north is in the middle. And that's all it is. But what's important to know is the difference between where your compass is pointing and where north is on the map. Because if north is here on the map and your compass is pointing to north over here, there's going to be a huge difference in here. All right, so what do you have to do? Well, we learned a little thing in the military. So if you have grid to magnetic, okay, if you have a general going to a major, then you subtract. If you have a magnetic to grid, you add, all right? In the civilian world, you have it's a little bit different because you have east-west, but generally speaking, in the northern hemisphere, general to major, you're gonna get demoted, so you're gonna subtract. Major to general, you're gonna get promoted, so you add, right? And that's really all it is. Magnetic to grid or grid to magnetic. That's going to help you when you plot a line to walk and you're walking there. That way you know, hey, I'm going to be 3 degrees off, and you're going to do all that addition and subtraction before you actually start walking. Okay, so let's get into the map, the terrain features, and all that stuff. So something like this, you have grid to magnetic, okay? And a lot of maps will tell you whether to add or subtract. It's pretty easy. You have grid and magnetic, and this is going to be the difference here, okay? And, you know, maybe it's like 3 degrees, all right? So all you have to do is look at your map, see what it says, and it's going to tell you whether you need to add or subtract, all right? But if you are walking a line like this, okay, and that's your grid going straight up and down, but your compass keeps pulling you over here because that's the magnetic north, okay? I can't write it very well. Okay, you are going to start drifting over this way. So if your point of domination is over here, you're going to keep drifting to the right because that's where your compass is leading you. So you always have to remember to look at the declination and see whether you have to add or subtract, okay? And again, it could be going this way, just depending, all right? Depending on where you're at and depending on where the North Pole is compared to where you're at on the map, okay? I believe, last time I checked, it was Maine that had the worst declination in the United States. So as long as you're in the central United States, you're not that bad, all right? So something I do want you to know is that in the military, this class is usually either 8 hours or 2 days. It can be up to 3 days, depending on how deep they get into it. This is more of a general overview, a really, really rough draft, and it's not intended to make you an expert by any means. It's more intended to make you go out and seek more information. If you want something like this is the FM 21-26, the Map Reading and Land Navigation Field Manual for United States Army. This has, let's see, it has, I don't even know how many. So it has hundreds and hundreds of pages, right? They're not labeled all that well. It has hundreds of pages of exactly how to read a map and how to land nav. This is basically an infantryman's Bible right here because we do a shitload of land navigation and we're out in the field all the damn time. So this is something that every infantryman should should know. I'm not going to say they do because some grunts are pretty fucking stupid. But this is something that you want to get. You can even find this on Amazon. I believe this came with the Boss kit that I was talking about earlier. And if you want to brush up on anything, that's a great thing to have. Okay, so on a map, on every terrain feature, you're going to have these things called contour lines, okay? Contour lines just basically tell you the elevation that you're at. Okay, so if you have a really, really thick contour line that goes something like this, and let's say it says 500, right? That's going to tell you exactly whether you're 500 meters, 500 feet, whatever it is in elevation. Now, you have another thing called contour intervals, right? So let's say you have another line out here that's really thick that says, I don't know, 200, right? So then you have a couple thin lines in here that don't have any on there, right? Well, you can tell if this is a thick one that says 200 and this is a thick one that says 500, this one's 300 and this one's 400, right? And that's just your contour intervals. Now, what makes this very, very important is when we talk about terrain features, all right? Because you're gonna see contour intervals either get really far apart or form a certain shape or get really close together, and that's gonna let you know what kind of terrain you're going to encounter. And when you're looking at your map and you're doing your route reconnaissance, you need to know what kind of terrain you're gonna encounter. That way you know if you need to go around something or you need to go over something, anything like that, okay? So basically, we can start with the first one. This right here is a hill, all right? How do you know it's a hill? Is because there are circles all around it. You're gonna have a high point in the middle, and just so you know, the contour interval on top of the hill, right there, would be 550. Why? Because there's no more contour lines in the center, so you cut this in half, all right? So a hill, you're gonna be on a high point, you're gonna have, on all four sides of you, the land is gonna go down, all right? Pretty easy, all right? So that's the first one. Obviously, this eraser is amazing. So, what happens when you have yes, it looks like a pair of boobs. I get it. What happens when you have two hills and you're looking at this terrain right here, right? This is called a saddle. Just like when you're riding a horse, you're gonna have low ground right here, high ground to two sides, and low ground right there and there, all right? Pretty easy, just like a saddle. I'm like a fucking Picasso on a horse, right? You sit here, you have low ground, high ground, high ground. Now, what if you have a series of hills together, right? So, what's this called? This is called a ridgeline. It's just a bunch of hills put together, and you're talking about the top of them. Pretty easy. Okay, so let's talk about if you have a hill here, right? And let's say you are in this area, this is where you need to go right here, right? So what do you think is in between two hills? This is a valley, right? A lot of times, not always, a lot of times valleys will have running water through there, or old water, or just an area for water to go. If you're in a valley, you're going to know it because you have hills on two sides, and this is going to be pretty open, all right? Okay, so let's say you're walking along, or let's say you're doing a map reconnaissance, and you're plotting your route, and you see this. Okay, this is called a depression. This is usually, you have high ground here, and this is the abyss that goes to hell, right? Not necessarily, but basically it's just a hole in the ground, okay? It doesn't have to necessarily be a circular hole. It could be really anything. It's just a hole in the ground. You need to know that because when it's dark outside and you're walking around in nods or it's raining or foggy, and then you fall into one of these, it hurts really bad, and then sometimes you break your nods. Just saying. So those are the 5 major terrain features. Let's look at the rest of them now, okay? This is I think should be a major terrain feature, but let's say you see this, right? You have contour line, then you have another contour line, then you have another one, and then you have another one, and then you have another one, okay? If contour lines get really, really close together, and let's say each of these is 100 feet, so you got 1, 2, 3, 4. So this is 500 feet right there, and usually they're this far apart. What does that tell you? That tells you the elevation either goes up or down very quickly, okay? So this would be considered like a cliff, okay? So if you're doing your route reconnaissance or you're walking and you're following your compass, this is something you want to avoid, because if you fall off of it or you come to it and you cannot climb it, both of those things are bad. All right, so you're gonna have 2 things like this, right? This is a draw. How do you know it's a draw? Because this makes the letter A. This is a spur, because this makes the letter U. Okay, so a draw is like you have high ground over here, and you have high ground over here, and you know how the high grounds kind of meet, and then you walk up there, sometimes there's like a little stream going down there. Draws, a lot of times, have a whole bunch of vegetation because that's where the water is going to go, because the water goes to low points. If you've ever been in, like, I don't know, Georgia or North Carolina or any other horrible part of the South where the military likes to take you, and you have to walk through this stuff in the spring or the summertime, it's possibly the worst thing in the world. Spurs are a little bit different. Spurs are usually, if you put your hand like this, and let's say this is a ridge line and these are hills. A spur is like a leg coming off of a hill, all right? So if you have a terrain feature that goes like this, and, well, let's see. Let's just leave it at that. So just coming off of a hill, right? It's like little fingers coming off, okay? Usually this is high ground right here, and then it has low ground right on three sides, and a hilltop up here, all right? The draw would be in between two spurs. This would be like this, and this would be like this. You understand my Picasso drawing? I think it's fucking beautiful. Okay. All right. The last two are man-made, all right? You have a cut and a fill, all right? So a cut looks like this, has these little tick marks, kind of like the depression. That means that somebody just cut a groove out of the ground. A fill is just the opposite of that. That means somebody put ground in there. Think of like a railroad track, right? So a lot of fills are railroad tracks, okay? And depending on how big they are or how much land they took out or put in, it just depends on how big the terrain is. Okay. So now that we talked about the major terrain features, let's talk about the colors of a map. Not all maps are going to be the same, but they're going to be very close. Blue is pretty much always water. Green is vegetation. This is a map of Utah, so there's nothing but brown on here. Green is vegetation. Black is usually man-made objects. And then depending on whether it's a military map or not, you're going to get, some red or red-brown or brown in there. Usually contour lines are always like a dark brown or a red-brown. And I've noticed that in the military, they like to teach you a certain way, but when you go to the civilian world, some things don't jive with each other. So you have to really take a good look at your map and read the legend and see exactly what it says. Like, let's say, for this one, a black and blue road is a divided highway. A red and black road is a primary highway. A yellow and black road is a select paved road. So a lot of those colors you're not going to see, or you're definitely not going to see stuff like that on a military map. So it just varies a little bit. So let's take a look at the compass and maybe some more stuff that you might need. Okay, so let's take a look at compasses. The only compass I don't have here is my military compass. That's actually in my like get home bug out bag, and I didn't want to dig it out. But we have a little array of other compasses here. We have a cheapy compass like this, and it's not bad, right? If you're lost, I would rather have this than one of those little super cheapy button compasses that you see like in little survival packs. Those are horrible. They don't keep their north very well, and if you drop them, sometimes they get tilted and jacked up. So you may not want one of those. This is a Brunton, what does it say? True Arc 3. Brunton True Arc 3. It's actually a decent compass, and this was the most expensive compass I have, and I'll get to that in a minute, but they don't cost that much. I think this was like 50 or 60 bucks, and 50 or 60 bucks for peace of mind that I know that the compass is going to work well when I need it to work is okay with me. With even both of these compasses like this, they have, like this one, the cheapy one, they still have a little thing on here where you can take and you can look at a scale and say, okay, this is 1 inch, and then take it over here and be like, okay, 1 inch here. You get a little scale on it. It tells you, read it this way, so it tells you which way to put it, right? And then when you get a bearing and you do your declination, and then you adjust your declination on here. Let's say it's 20 degrees, for example. Bam, it's like that. Now I do what they call put the dog in the doghouse or put red in the shed. So when you adjust your compass, I don't know if you can see that on here. I'll take a closer look. When you adjust your compass, you're going to have your north, and then you're going to have in here when you twist it, a little red. This one's an arrow. You can have a red arrow or a red box. That's what you're going to put on your declination. Then you're just going to put your north-seeking arrow in the box, and bam, now you know where you're going. Pretty simple. This one's the same way. This one can actually adjust your declination for you. It has a little yellow ring on here, and you can adjust the declination that way. It says east and west declination. Again, so civilian, east and west, military, add or subtract. This is a little button compass, but it's a Suunto button compass. These are the best button compasses on the market. They're way more pricey than a regular button compass, but I would actually trust my life to this little guy. These are pretty awesome. And you can pick these up for, I think, around 20 bucks, something like that. This is another Suunto compass. This is the Suunto MC2. Yeah, Suunto MC2. So from all the dudes that I watch on YouTube and all the like survivalist guys and stuff like that, every one of them say this is one of their go-to compasses because of how good it is. Every compass that you use should have, a good compass in there. You should be able to change the declination, and also you should have the scales. And this one, you can see the mirror on there has a signaling mirror. Plus, when you put it down and you aim it, you can aim it and aim up all the lines, and then you can see where you're going. Right? It's got a little thing here, almost like a front sight on a pistol. And the military ones are really good about this too. You just hold it up and you can aim where you're going. Something about that, just a little tidbit of information that I was not told in the 90s when I first joined, and I didn't get told for a while. When you are walking your designated path, instead of having your compass like this and just like staring at your compass the whole time, all you do is you look where you're going, you look up and you go, hey, that big ass rock over there, I'm gonna walk to that rock. You walk to that rock, you know you're on your line, and then when you get to that rock, you take another compass reading. It's way easier than sit here staring at your compass as you're walking, okay? Another thing about compasses, if you have a lot of metal on you, like right here, I just take my watch and go to the compass, and you can see the needle move, right? So when you do compass stuff, you want to make sure it's out here and there's no metal around it, because the metal can draw the needle off. Another thing is when you're walking, let's say you're walking and you come up to a lake, right? Well, how do you get around a lake? There's this thing called the box method, where you're on your path, let's say it's 180 degrees, and you know that you have to walk 3 clicks, right? 3 kilometers. And 2 kilometers in, you hit a lake. What do? You take an abrupt right or left, and then you do a pace count till you're at the end, and then you take another abrupt right or left, do a pace count on the end of the lake, and then it'll be easier if I do this. So you're walking, here's the lake, you come up here, you take an abrupt right, you do your pace count, so let's say it's 25, you go up, you add this to this pace count, so now you're still on track, and then you go the same distance over, 25, and then you just continue walking, okay? It's called the box method. It's something really simple. If you get to a giant lake that's really, really big, it's a little bit harder to do that. Sometimes you just got to get wet. But that is a really good method if you come to small lakes or like a little canyon or something like that. Speaking of pace counts, so if you look on a map, my sweet ass eraser here. So if you look on a map and let's say this is where you're going, and you started over here, and this is 3 kilometers, right? How do you know how far you've gone? In the military, we use this thing called ranger beads, where you take your pace count, and we'll get to that in just a second. And then every 100 yards, you pull down one of the beads. Every kilometer, you have 9 of those beads. When you get down to the 9th one, another 100 yards, you put those back up, and you pull down. There's 2 different kinds of beads, so it's just a thing like this, it's got beads here, then there's a knot, then it's got beads here. You just pull these down, and then when you get to 1,000, you pull this one down, and that's 1 kilometer, and then you keep going. Another method, you can put rocks in your pocket, or every 100 yards you put a rock in your pocket. If you start counting on your fingers, you're gonna get lost. I mean, you fall down, all of a sudden you lose count. So it's just a good way of tracking where you're at, right? So pace count. In the military, it's every left foot. Every step with your left foot is gonna be 1, okay? 1, 2, 3. But you have to know your pace count for no ruck, pace count with a ruck, pace count uphill, pace count downhill, pace count on the side of the hill, 1,000 different pace counts. A pace count when you're super tired, you're walking slow, a pace count when you're very refreshed. And we write all this stuff down. That way when we go do our land nav, we know exactly how far we've gone. One awesome thing I learned when I was at a certain school was, let's say this is where you're going, and all of a sudden you end up over here, and you're like, where the fuck am I at? Well, they do what they call the funnel, right? So they go, okay, you're going this direction. This is your funnel, right? How far could you have traveled in 2 hours? Well, if you could have traveled between here and here in 2 hours, then this is where you're at. What's your natural line of drift? Usually if you're right-handed, it's right, and if you're left-handed, it's left. So most of the time you're gonna be in this box. And then from here, you can use your terrain features to find out where you're at, okay? So, I talked about natural line of drift. A really cool thing I learned in the school that I went to was they had a course that every 10 meters, they had a pole, okay? We're just gonna pretend like it's every 10 meters. From here to here, this was 100 meters, okay? So what you'd do is you'd start at a stake, you would get your degree, so let's just say this is 360, right? And what you would do is you would start walking, okay? And you would do your pace count of 100 meters, whoop, and see where you ended up. Now, depending on the terrain, I'd sometimes end up all the way over here. So I thought I was walking in a straight line, but because I'm right-handed, because I favor that side, my natural line of drift took me like that. And depending on the terrain was how bad it was in between here and here, okay? The cool thing about this was they had this on a couple different terrains, and you really got to see how bad it was. The worst mine was ever was 20 meters. 20 meters, right? But that's over 100 meters. So if it goes over 200 meters or 3 or 4 or 500, you can see how bad that would get, right? So that's why every 100 yards, every 100 meters, either you look at the big rock like I was talking about and walk right to that, or every 100 you pull out your compass, you get a new bearing, okay? If you do that, that's gonna keep you on track, all right? So what happens when you get lost, okay? Well, you could do a couple things, okay? You can take a resection. So let's say this is you. Let's say you look out there and you find 2 major terrain features that you can identify from your map, all right? So let's say there's a mountain over here, and let's say there's a radio tower over here, or another big mountain, or whatever the fuck it is. You take a degree here, take a degree here, okay? And then from there, depending on what this is, you either add 180 or you subtract 180, because there is 360 degrees in a circle. Are we following? There's 360 degrees in a circle, so to get the back azimuth, because you want to see this, you're going to get a back azimuth, right? And you're going to add 180 or subtract 180, depending on what side of the 180 you're on. From here, once you get a back azimuth, you go on your map, you find this, and you use this back azimuth, right? You look at your map, you use the back azimuth, and you draw a line. Use the back azimuth, you draw a line. Wherever those lines intersect, that is where you are. That is called a resection. Now, let's say you're out walking around and you actually come to an intersection in the road, okay? you use the funnel method to kind of determine kind of where you're at. But let's say you found a road and it goes like this, right? Let's say there's a T in the road and you're right there, okay? What you can do is you can get an azimuth here, here, and here, okay? You take those 3 azimuths, right? And you look on your map. More than likely, there's only one intersection on your map in that little area that you should be in, that you triangulated where you might be, that's gonna have those same azimuths. So all you do is write those down, you go back to your map, you sit down, you look at the roads on your map, and sure as shit, there's probably gonna be an intersection like that. You get out there, you do the azimuths on your map, and if they're right on or they're super, super close, then you know what, that's more than likely where you're at. Now, if you use the funnel method and you see a major terrain feature like a waterfall, and let's say that's the only waterfall in the area, or you're in Kansas and there's one hill in the entire state and you're by that hill, you can also use that. Common sense goes a long ways when you're talking about land nav, but those are just a few methods to use. One of the other methods to use, and it's a pretty good surefire method, is to use a GPS. Okay, so let's talk about how to navigate on your map, using your map. We've kind of hit all the major high points on how to walk in the woods. Let's talk about using your map, right? Some of the things you're gonna need if you wanna go out and you wanna start doing land nav, you're gonna need a protractor. Make sure it's the right size protractor for the right size map. This one is not, so I would have to get a different one. Make sure you get some like 3x5 cards. What this is great for is if you want to look at, let's say you want to go this far and you can coordinate with the map. Okay, that's going to be on this map about 1.5 miles. Pretty easy, right? Let's say you want to look how far you went, but you've been traveling down a road. You can also use this and just kind of go along the road. Using a string is way better. Just put the string on the road, and then when you straighten out the string, you can use it and see how many miles you've gone or how many kilometers you've gone. You can also use like little tick marks on this and just keep turning this down the road and then look and see. Same concept. This is also good to look and see how wide the river is that you think you may have to cross. Because, you know, you never know. Maybe it's just a stream or maybe it's a big river. And if you need to cross it no matter what, then you need to prepare for what you need to do. One thing that you definitely need to do is when you get out there and you're figuring out where you're at, the very first thing you need to do is orient your map, okay? What that means, very simply, is if I'm facing this way and there is a big giant mountain right there, I need to put my map down to where the big giant mountain is right in front of me as well. Super easy. Some people say align north with north. That doesn't always work for me. My brain sometimes doesn't work that way, especially if north is turned around. So what I do is I just orient it with the terrain features around. Whether it's a river, a hill, an intersection, a city, whatever it may be. So one thing to take note of is when you're plotting your course, you always want to make sure that you're not making it harder for yourself, okay? So if we look at the map and we see a bunch of, contour lines that are super close together and that indicates a cliff, but your route takes you off that cliff, you are not Wile E. Coyote and you are not going to survive. You are probably going to die. So what you need to do is plot around that cliff, right? And if you do it the right way and you actually take your time before you even step out and you take your time and you plot a good route to get where you're going, it's going to make life a lot easier and you're actually going to get there a hell of a lot faster. So there's a lot of tools that you can use when you're land navving, when you're out there using a map and doing some land nav. You can use a little magnifying glass, right, like this, to where you can look and you can see a little bit better of where you're going. Or maybe you can't see the terrain all that well. They have little things like this, right? That on one side there's a compass, and on the other side there's true grid and magnetic north, and it tells you, all the declinations that you want to do, and if you need to add or subtract. Little tools that tell you the in kilometer of a slope, how steep the slope is, right? Stuff that'll tell you latitude and longitude. That's how all maps are made, with latitude lines and longitude lines on the Earth. And basically they just keep condensing down until you get to a small map like this, or grid squares. All this stuff, a great resource. You can go to, let me see where that, maptools.com. That's a great source to look at all this stuff. Like I said, the FM 21-26, it's something that every infantryman out there should know. And I say infantryman only because I come from the military background. There are dudes out there that do this in the civilian world that are probably way better than any Army guy. There's dudes out there that, live out in the woods, and I'm really horrible at latitude and longitude, or minutes and seconds. I'm really good with MGRS and 10-digit grids. Those dudes that are good with minutes and seconds, there's probably 1,000 people out there that are way better than all this stuff than I am. And I think it's awesome. Places like REI do like map reading and land navigation classes, and I believe they're for free. So you can take maybe a local map, right? You take it up there and say, hey, my next trip, I want to go whatever to this campground, and they're gonna be like, all right, well, let's do this. And then maybe you have maybe you have a 5-mile walk to get to the campground, and you want to make sure that you know what the hell you're doing. You can go to your local REI, and they can help you out. If it's not REI, any other sporting goods store should have stuff like this. I know REI, you could buy, they have a bunch of maps. Bass Pro Shop has them too, for like hunting and things like that. Always go with a topo map, because you're gonna want to see the terrain. Another really good thing to do is when you get your map, to laminate it. The reason why is because you can use these little things here, right? These are called map markers, and yes, I still have them. And you can mark all over your map with them to see where you're going, to see where you want your route to be, and then you use this little guy, who it's an eraser, right? And I don't know why they don't sell them together. It doesn't make any damn sense to me, but sell them together. You have a little pocket here, or a little group of them, and you can put all your stuff in like a little Ziploc bag, and you'll be good to go. And remember, when you're doing land nav, the more precise, the better. So we always had little notebooks, or like I said, 3x5 cards, or anything like that, and you write down everything. You write down where you're starting, where you're going, how long it's going to be, how long you think it's going to take you, the route you're taking, major landmarks along the way. I know that helped me out a lot in some of my land nav classes. Hey, I'm starting at 07. My estimated time of arrival is whatever, 1000, and I'm going to go past, Big Baldy Rock and whatever river, this, that, and the other. And that just keeps your mind on track, because when you're out there walking alone, if you're, sightseeing or something, you're taking pictures, you can get lost really quick. If you kind of veer off the trail for a minute and you're following whatever bird or snake or whatever, bighorn sheep you're looking at, if you get off the trail for a minute, you turn around, then you're completely lost. So if you have a little, I think last time I went to Pikes Peak, I had like a little fanny pack, and it just had this stuff in it to where, hey, if I get off the trail, I can break this stuff out. I know where the hell I'm at, and it's not that hard. Another thing that I always suggest using is a GPS. I am not a GPS expert by any means. I just know how to get my grid, and to look that grid on the map is basically what I use a GPS for. I think it's because I'm so old and I'm so used to using just a map and a compass. I can take that GPS, I can get a grid, I can coordinate that grid with the map, I can locate where I'm at, then I can orient my map in the way I need and see where I'm going. And a lot of times, when you're walking out in the woods, you think you've gone 4 or 5 miles, but in reality, you've probably only gone 2, because what you walk on flat ground in a little field that's open is completely different than what you're going to walk in the mountains when you have a backpack on. And that's why you got to get your pace count in all different shapes and forms. If you have any questions, or you want any more resources or materials, hit me up in the comments. I will help you out in any way I can. I can point you in directions of other people that are land nav experts, and I'm not an expert by any means. I just did this stuff for a long time, so I am fairly knowledgeable in it. But if you have any questions, hit me up. And remember, at the end of the day, ask yourself, are you an asset or are you a liability? You can go, where's a good place for maps? I don't fucking know.